Yeah, thank you very much. Okay, well, thank you. I we asked ChatGPT about an illustration on when if we were going to land a cable on Svalbard, and this is what they came up with. So it's the cable is interesting. The only thing that was nice it was this suit, so we bought some of those for doing the operation in up north. Space Norway. I'll talk a little bit about Space Norway because it's not known to everyone, I think. A little bit about subsea cable systems and how we protect the subsea cables, which is an increasingly, I would say, focused topic these days. We also had to do a repair on the cable that we have today. I'll talk something about that because that's of interest, I think. Arctic Way, which is a new project. We're going to talk about the status there. So, Space Norway, we're a leading satellite operator. We have a broad product and service portfolio, and we have both commercial and governmental clients. There was a change in like 1.5 years ago, because then Space Norway took over Telenor Satellite Services. Then we went from like 50 people to 180 people. And I've been in Space Norway for like 10 years, and then I was employee number 5. So we had quite some development, I would say. So I think one of the reasons why it makes sense to have Space Norway take over Telenor Satellite Services is that we are 100% owned by the Ministry of Trade, Industry and Fisheries. So we're a society over there. So we have to generate our own income, but I think it's important these days that this is now under complete Norwegian governmental control. We're also subject to the Norwegian Security Act. We have a wide range of operational services. We have quite a few satellites coming from this Telenor satellite, Thor 5, 6, 7, which is we are geostationary satellites, broadband services for maritime customers, broadcast services, which is still quite popular on our satellite, particularly in the Nordics and Eastern Europe. We also reach the Troll station in Antarctica, and there is also some emergency communications to Svalbard. We have the Arctic Satellite Broadband Mission, which is it's a constellation of 2 satellites that have been developed, and they were launched on a SpaceX rocket last summer. But it's quite an unique achievement because it's a combination that we have governmental and commercial broadband services. So one of the payloads is owned by the U.S. Space Command. The other one is the Norwegian military, and then there is one civilian, you could say, part, which is Viasat. So by combining these things, we were able to launch these satellites, and they are using high elliptical orbits, meaning that, yeah, elliptical, you know what that is, but it's really it's very high above the Earth on the northern end, like 30,000 kilometers. And on the southern side, it's really close, so that by having 2 satellites, it's possible to have a full coverage, 24/7 coverage of these 2 satellites. We're also dealing with the AIS satellites, which is operated by Statsat. We are operating those. Those have 2 identifications for ships. We have the Svalbard cables put down in 2003. I'll talk more about that. And we also own 50% of Kongsberg Satellite Services, which is a world-leading provider of ground services and Earth observation services, and it's primarily polar orbiting satellites. That is the key there. We have quite a few development projects, application development, infrastructure in space. It's like Internet of Things program for satellites. And also the study of secure distribution of position and time, as has been a topic here, is a part of this program. We are going to build a new geostationary satellite called Thor 8 because the existing ones are growing old. So we need to replace that with a new one with more capacity and further reach so that we can keep on the service. We have a radio now, a radar satellite being developed, a constellation with that, so they can use for Earth observation and could detect chips, for instance, that they have switched off their AIS or they have lost power and they are in trouble or things like that. So it's very interesting program for some. Arctic Way, I'll talk about that, but there's a new submarine cable coming, going to Svalbard and Jan Mayen, and also a new generation of this highly elliptical orbit system because the one that we launched last year, it's already full, so there is an interest of capacity. As Marius said, I'm originally an engineer in the optical space. Very old, as he said, but this is actually the world of submarine communication cables. I mean, probably most of you are aware of that, but 99% of all international data goes over subsea fiber optic cables. And you see the continents are connected, and you also see that there are some fairly complex areas that are really critical. For instance, through the Red Sea, between Europe and Asia. As you know, I mean, situation there in that area is not nice. I mean, cables are cut, and the ships are not allowed to enter there because they will be fired at. So there are programs to try and find alternative routes. Microsoft have launched a system that goes south of Africa from US to Asia. And there are, from the Nordics or Europe side, there are programs to try and go from Europe to Asia, either over the northwest passage or even over the North Pole. There is an initiative called Polar Connect that's working on that, but it's long, it's difficult, and it costs a lot. But there are alternatives there being worked at to overcome this challenge of the communication between Europe and Asia. The Svalbard cable system was built in 2003. There are two cables, about 1,400 plus kilometers. It's a repeated system because of such distances, the light is attenuated and it has to be upgraded. So it's optical repeaters that the optical signal is amplified by erbium doped fiber amplifier systems pumped by lasers on the bottom of the sea. It's been operative since 2004. It was originally a 10 gig direct detection system, but it was upgraded in 2014 to 100G. So it's a very, very powerful system, and it's also very reliable. We had the only time we had a real down on this system was in 2014, and that had to do with the upgrade. We did the upgrade, and we also moved from one site to dual site to obtain redundancy, but then the fault happened. The clients are Kongsberg Satellite Services. They have, again, customers like NASA, NOAA, ESA, even the Galileo system, that the European timing system, has a station or a node at Svalbard, so it's a critical thing. SICT, University Research Ny-Ålesund Connection, and the Telenor Svalbard. And today we are actually using 30 gigabits per second of this system. It's not a lot, but that's how it is. And I did some calculation here, and that and we have 8 fiber pairs on 2 cables, and total capacity could be like 50 terabits per second. So we have to build a new cable, but it's not, as you see, it's not because we are out of capacity. It's to do with age, and that we need to know that we have a reliable connection to Svalbard, because it's very critical for Norway and for these installations. So how do we protect the subsea cables? Well, as you see on the right here, we have had some situation in the Baltic Sea. We also had a damage to our own cable. So there is a lot of attention around this. So careful planning, of course, is important. We do desktop study, we do cable route survey. I'll talk about that actually for the system that we are building today. The right selection of cable and protection methods, cable armoring, and we are burying the cable in the risky areas with the ongoing fisheries, anchoring, and so on. So the current, I would say, status is that we're burying the cable down to 1,500 meter water depth. Below there's no fishing, at least, but there could be, then it's open. There, we could monitor service threats, etc. We have membership in organizations offering subsea cable repair services, like Atlantic Cable Maintenance Agreement, for instance, that we have access to ships that can come out and repair in case of damage. And there are membership organizations that we are part of to share challenges and find solutions. So we recently established the Norwegian Subsea Cable Association, that we're a part of the board in that organization, and that's supported by NCOM, for instance. As said, we had a cable fault in January 2022. On January 7, actually. It was a break then on one of the cables, but after 14 days, the redundancy was restored. I mean, we have 2 cables, so this connection to Svalbard was never down, but the redundancy was out for like 14 days. There was an investigation by the police, but no conclusion was, they couldn't conclude anything. And the cable was fully repaired summer 2023, actually. So this is this misprint here. It was in 2023. But as you see on the picture here, this is repaired, or the cable that we took out, that there has been some external stress on it. I mean, the coating is gone, and it's been a stretch, and then what we experienced was a shunt fault, so that it was connection with the electrical conductor to the subsea, to the sea, and then that's quite effective grounding, to put it that way. So, but then the fiber was intact, so we could, by powering from each side, we could keep the cable alive. But we did the repair in 2023 by a cable repair vessel, 100 meters, 50 persons on board. Cable Vigilance was the name, mobilized from Calais. So we did to repair the cable. We first had to pick it up by this well, quite heavy dredge. So it was put down to the bottom of the sea, 2,500 meters, and then picked up like fish. And then here is, you see that there is on deck there. So that it took like 16 hours. So it's important that you know that you actually have, I mean, you have actually the cable. If not, you have to start over again. So when we had it up to the ship, we removed the damaged cable, and then they have all the competence with splicing, etc. on board. So that was done on ship, and then they had to mold this this splice with this mechanical housing arrangement, and at last was put in this red splice covering. And then the funny thing for a nerd like me, I could put my signature on the splice there, and it was put down on the bottom of the sea. So I have my signature there. I think that's cool. Okay, I said that the existing cable is growing old. It reaches technical design life in 2028, so we have been working a while for preparing for a new cable. I mean, as you heard, it's not because of we haven't enough capacity, because there is a lot of capacity, but the aging and the technical design life is like 25 years. So the plan was also always to put a new cable up to Svalbard before 2028 to make sure that there was a connection to this strategically important place for Norway. It also looks now like the existing cable is probably going to last for longer than 2028, because all the end equipment, also the powering equipment, has been changed. So the weak thing, of course, is the electronics on the bottom of the sea, but there's no degradation seen there yet. So it's fairly stable and operating well. It's defined as a critical infrastructure, as said, so it's important to have a new system in place. So there was a strategic initiative to build this system to Longyearbyen, but also it came up that there was a need for a connection to Jan Mayen. And then it made sense to build this as one project due to both time and cost savings. I mean, you could do it with one mobilization. You could do it within a quite condensed time, and so on. So the Arctic Way was approved by the Norwegian Parliament on March 25 this year. We had the contract in force with Subcom to produce and lay the cables from Bodø to Svalbard and Jan Mayen. That was on March 31, so you could understand this was a kind of a tight race, because we needed to have that contract in force by that time in order to be able to do the marine survey this summer. because in this area you have a limited time for operating at sea. You have a defined weather window, which is May, September. I mean, outside that you cannot do this work without risk of waiting along on weather and challenges with that. To Jan Mayen, of course, Norwegian Armed Forces is the primary customer from Bodø to Jan Mayen, and we're also laying a cable from Bodø to Fauske in that fjord as a part of the project. And there's a lot of applications needed to the authorities to plan the cable route, for the mapping, and for being allowed to land and all these things. So the Arctic Way, it's really the world's northernmost repeated subsea cable system, and what we have ordered so far is a so-called open cable system, which then terminates optically, but there is no interface, I mean customer interface on that system. So that's an upcoming thing this autumn to have a request for quotation on submarine line terminal equipment to be able to provide services. We have terminal stations in Bodø, Jan Mayen, and Longyearbyen, about 2,500 kilometers of so-called SL17 cable. That means that the diameter of the cable is 17 millimeters. So it's not a very thick cable, it's a very thin one. So this, in most of the sea, it's that dimension. I mean, below 1,500 meter water depth, this is the dimension. But when we get into shallow water, when we are doing the burial and things like that, there is more armoring onto it. So you have that on top. There are 25 optical repeaters. So the optical signal is then repeated in 27 repeaters. And we also have system powering from all 3 landings. So there is redundancy there. If there is a cut of the cable, then you can have powering from the other sides. And also important, it will operate as a redundant system together with the existing cables. So that for as long as the existing cables live, it will be a redundant system. So as I said, the existing cables have not shown any sign of degradation yet. And statistics tell that these optical amplifiers on the bottom of the sea, they are very, very stable and can work for long if they are left alone. Because the environment up there is also stable, and low temperature keeps things cool. So a few more details. Branching unit cable, undersea cable, as I said. Repeaters are the subcom repeaters. They have built-in redundancy, so they have more than one pump to secure the powering. And we also have 5 kilovolts power feed equipment, and there is also quite some monitoring equipment to continuously follow what is going on the cable. I mean, there is a special OTDR function so that you can actually see through the optical amplifiers, so that we can, if something happens, if there is a fall, if there is a cut, we can actually see that with a very high degree of accuracy. So this is a plan of work. We are in the middle now of the cable route survey. Come back to that where we are. It's been a good summer in that respect. We've been lucky with the weather and everything. And based on this survey, we will then establish the final cable route, which is by the end of the year. And based on that cable route, they will start producing the cable, because I mean they will know then how much of the armored cable, for instance, that is needed, where you need to bury it, and so that's really quite detailed study. I mean, what type of cable you need for different depths, and there also are mountains, there are valleys, all these kinds of defines what kind of cable we need. We need also to build and install cable landing stations, beach manholes, and all these landing sites should be finished then by Q1 27. And then the marine installation starts, the main lay of the cable in 2027, and by end 27 we will do testing and acceptance of the system, and it shall be ready for service like summer 2028. So there are quite a few challenges by doing this up north. I mean, we have this short weather window, as I talked about. We have complicated landing conditions, frequent earthquakes, a lot of things. Now they say that I'm running out of time. So we have almost completed the survey, marine survey. We have been lucky with the weather. We are now in Bodø, so we have done all these lengths from Longyearbyen, Jan Mayen, Svalbard. So we are now in Bodø, and they are actually in port in Bodø today. So it's close to finishing. And one example of how complicated it can be. I mean, this is north of Svalbard. I mean, it's like Lofoten underwater. I mean, you see here you can be like 3,800 meters there in the middle of the suggested route, and there are mountains, and we need to find valleys. It's steep and it's very, very complicated. So you actually have to do this study like almost meter by meter, and you could say that it takes a while, because in total we will do like 6,000 kilometers of survey lines to make this cable. So that was an example, and yeah, that's it.
Thank you very much. Any questions?